Hey Geometry, we are working in chapter 12. It is the last chapter of the year. It's the last chapter of the whole book. We've almost gone from cover to cover. That is exciting stuff. So the first part is just some vocabulary that actually comes from 12.1. We are dealing with three-dimensional figures. It says all of the surfaces of the solids so far are flat surfaces called faces. So this particular shape has 6 faces. This one here has 7 faces. You could count the number of faces. Now where your faces intersect, where the faces touch, those are the edges. Okay, so where your faces intersect, that makes an edge, that makes a line. Down below it says a prism is a polyhedron with 2 congruent faces that are polygons in parallel planes, and those are called the bases. So here's what you need to know, this is important. A prism is going to have 2 congruent faces, and we call those the bases, and they are parallel. All right, so prism, you're going to have 2 bases. They are congruent. They are parallel. All of the other faces are called lateral faces. So for this particular example, the prism that we see, this shape right here, which is a pentagon, is the base. Now the reason that I know that it's the base is because I see this one right here. And then if you look at the back and kind of follow my pencil here, I see this one right here, and those 2 are parallel and they're congruent. That's why I know they are the bases. So sometimes it's easy for students to think base means bottom, but that is not always entirely accurate because it's going to depend on how your three-dimensional figure is sitting or standing. So for this one, we don't want to think that it's the bottom, because that would indicate this rectangle down here, which doesn't have another face that it is parallel to, which is why it is not the base. Now when we have prisms, again that means 2 bases, parallel and congruent. The way we name them is by the shape of the base. So remember we said that the pentagon here is the base. So this would be called a pentagonal prism because we're naming the prism based on the shape of the base. Remember we said the bases were pentagons, so there we go. So at the very bottom it says a regular prism. Now let's just talk for a minute about that word regular because we've talked about that word for many chapters. We said a regular polygon is a polygon where all of the sides are the same and all of the angles are the same. So remember we said it's equilateral and it's equiangular. Here, a regular prism is going to be a prism where where the bases are regular polygons. So in other words, like a cube. You know how a cube, each side is a square. All of those squares are the same size. They're the same shape. They're regular, okay? So that is a great example of a regular prism. All right, then it says that polyhedron that has all faces except one intersecting at a point is a pyramid. All right, so for this particular shape, and one thing to note is that a pyramid only has 1 base. So remember, a prism has 2 bases. A pyramid only has 1 base. And this one has a base that is a rectangle. So if I were going to name this, I would name this a rectangular pyramid. Because again, you're going to name it by the shape of the base. All right, a cylinder is like a prism. Remember we said a prism has 2 bases and the bases are polygons that are parallel and congruent. Well, a cylinder is exactly like that. The only difference is that the base is not a polygon, it's a circle, which is why it gets a different word. It's a cylinder. But think of those 2 things as being very similar to one another. Same idea. 2 bases that are parallel and congruent. Cones are like pyramids because there's only 1 base. But again, the base is not a polygon. The base is a circle. That's why it gets its own special word. And then we also have a sphere, which is basically like, well, like a ball, right? Like a basketball, tennis ball, whatever. It's three-dimensional. Down at the bottom just says that a polyhedron is regular if all of the faces are shaped like congruent regular polygons. And this is just some facts for you. Platonic solids. Here you have the tetrahedron, the octahedron, the dodecahedron, the hexahedron, and the icosahedron. You don't really need to necessarily know those definitions, but it is interesting to just kind of know what a platonic solid is. What I for sure think you need to know are those shapes, right? And those you probably already know. So all of that covers 12.1, just the vocabulary behind three-dimensional figures. But what we're going to be focusing on for the first part of chapter 12 is we're going to be focusing on surface area. Surface area is when you are trying to find the area of all of the surfaces. It's kind of like at Christmas. When you go to wrap somebody's Christmas present, you're covering all of the external surfaces. You're not concerned with what's inside of that three-dimensional figure because that's a volume. What you are concerned about is covering that three-dimensional figure, and that is what surface area is. So surface area is when you're finding the area of all the surfaces. So in simplest form, let's say you had a Kleenex box and you wanted to find the surface area. Well, I could find the area of the top rectangle and the bottom rectangle. Those would be the same. I could find the area of the front rectangle and the back rectangle. Those would be the same. I could find the area of the left rectangle and the right rectangle, and those would be the same. And then I would add all of those 6 sides up. That's how you can find surface area. But we also do have some formulas that make it very helpful when you know what the shape is, and you can find surface area maybe a little bit more easily than finding the area of every single surface that you have. So we're going to start off with talking about prisms. What if we have a prism? How can we find the surface area? So we have a formula, and it is T equals capital P times H plus 2 times capital B. Let's talk about what those letters mean. Capital T stands for your total surface area. So that's your answer. If I'm trying to wrap a Kleenex box and I want to know how much wrapping paper I need to find my surface area. Capital P stands for perimeter of the base. That's important. It's not just perimeter. It's of a something specific. It is the perimeter of the base. So you have to be able to determine what the base is, and then you have to find the perimeter of that. All right, little h is the height of the prism. Don't get that confused with the height of one of the faces. It's the height of the prism. In other words, what is the distance from base to base? How far apart are the two bases? That's what the H represents. How far apart is base 1 from base 2? Capital B. Now that's easy to think of base, and that does have something to do with it, but it is not just base. It is specifically the area of the base. So here's what we need to know. First of all, you have to be able to determine what is the base. If you can figure out what the base is, then you're going to have to find the perimeter of the base. You're going to have to find the area of the base, and you're going to have to find the distance between the two bases. And if you can find those 3 things, then we can use this formula. So we're going to go ahead and get started with example number 1. We're going to find the surface area of the rectangular prism. Now remember the idea behind base. In a prism, you're going to have 2 bases. They are parallel and they are congruent. Now when you have a box, like what we have right here, otherwise known as a rectangular prism, you have lots of options for the bases because the top and the bottom, those are parallel and they're congruent. The front and the back, those are parallel and they're congruent. And the sides, left to right, those are also parallel and congruent. What a lot of students typically find to be the easiest here is just to do the top and the bottom. So that's actually what I'm going to stick with, is the top and the bottom. So here's the formula we need. T equals PH plus 2B. Now remember we just said that I'm gonna do top and bottom. So I'm just gonna highlight one of them just so we can have a visual there that we're gonna use that for the base. So here we go, off to the sides where I'm gonna do a little bit of work. I'm gonna find the P, the H, and the B. Remember, P stands for perimeter of the base. I just highlighted the base in yellow. Perimeter means the distance around that shape. So if I'm looking at that shape, I've got 7 feet, 11 feet, another 7 feet, another 11 feet. If I'm gonna go all the way around that shape, I've got 7 and 11, and another 7 and 11. Remember, perimeter means the distance around the shape. So I'm gonna add all of that together and I'm gonna get a value of 36. So hopefully everybody feels okay with perimeter. That is just the distance around your shape. All right, let's talk about H. Remember we said that H is the height of the prism, and what I wrote down was that it's the distance between the two bases. Okay, so I highlighted that one in yellow, and hold on, a little slow here, I should have had this out already. Let me highlight the other base here in orange. Okay, so those are our bases, top and bottom, right? Well, the distance between them is that blue line edge right there. So how far apart is the bottom yellow base from the top orange base? It is 4 feet apart from one another. They're 4 feet apart. Does that make sense? All right, capital B. Now remember, capital B doesn't just stand for base, it stands for area of the base. So what I asked myself is, okay, what shape do I have? I have a rectangle. How do I find the area of a rectangle? Well, that's base times height, or length times width, whichever you would prefer. So in our picture, I'm gonna do 7 times 11. And I'm gonna get 77. Hopefully everybody feels okay with that. So I'm asking myself, what shape am I working with? I'm working with a rectangle, then I need to know the formula for a rectangle. So remember in the previous chapters, we have been learning formulas for shapes. We've done trapezoids, we've done triangles, we've done rectangles, we've done lots of shapes. That's where it's gonna come back. You gotta know your formulas. So now we're gonna come over here to this new formula that we have learned, because all we've done over here is stuff we should already know how to do. Now we're gonna take these numbers and plug them into the new formula. So in place of P, we're gonna put 36. In place of H, we're putting 4. Then we have 2 because that's a part of the formula. And in place of B, we're putting 77. And now we're gonna math it up. So 36 times 4 is 144. And 2 times 77 is 154. And we're gonna add those numbers together and we're gonna get 298. And because we're finding area, we first of all need to have units, which are feet, but area is always squared. So if we were trying to cover that box with material, we would need 298 square feet. So basically, lots of stuff we've already learned are coming back into play to be able to plug it into a new formula. That's it. All right, so let's take a look at example 2 because we want to find the surface area of this triangular prism. So again, I already know that this is the formula I'm using because that's the formula to find surface area of a prism. Now let's keep reading. So it says, find the surface area of a right triangular prism with a height of 20 inches and a right triangular base with legs of 8 and 6 inches. Let's start with, it says that we have a prism whose height is 20. So a lot of times it is easy for students to say that this right here is 20, but that would be incorrect. Remember we said that the height of the prism is your distance between the bases. We already know what shape our base is. The bases are the triangles. So how about I highlight again? So there's one base. Oh, come on. Here is the other base. All right, so the distance between those is that blue line right there. That is the height of the prism. Remember, got to know the vocabulary. So height of the prism is going to be your distance between your bases. Now let's look at the other numbers. It says we have a right triangular base, so that tells me I'm going to have a right angle. I'm going to put a box in my picture. And then it says the legs are 8 and 6. Remember, the legs are the two sides that make up the right angle. So 8 and 6, it doesn't matter which one you decide to put where. How's everybody doing so far? We doing okay? All right, so let's start with capital P. Remember, P stands for perimeter of the base. The base is the triangle. Perimeter means the distance around the triangle. Well, we have a problem because I only know two sides. I don't know the third side. So guess what? We have a right triangle. What do? Ta-da! We use the Pythagorean theorem. So I have 6 squared plus 8 squared. Those are the legs. I'm going to set it equal to c squared because we are missing the hypotenuse. Now, some of y'all might recognize this one, and if you do, good for you, because then you don't have to do all this work. So I have 36 plus 64, which is 100. Good news, that is a perfect square, and our missing side is 10. So when I go to do the perimeter, and remember this means the perimeter of the base, and the base is the triangle. So I want to go the distance around the triangle. I'm going to add 6 and 8 and 10 together, and that's going to give me 24. So the perimeter of the base is 24. H. We've already talked about that. That means the distance between the bases. We've already identified that that is 20 inches. And now we're going to do capital B. Remember, that doesn't just mean base. That means area of the base. Remember, our base is a triangle. How do we find area of a triangle? We do 1/2 times little b, which is base, times little h, which is height. That's dealing with the triangle, not the whole prism. We're just focused on that triangle. So remember, when you're trying to identify the base and the height in a triangle, they need to form a right angle. And clearly I can see a right angle because I put it in the picture. So my base and my height are going to be 6 and 8. So 6 times 8 is 48, and then chop that 48 in half, and we get a value of 24 for capital B. So again, capital B means area of the base. We had to recognize that we needed a formula for area of a triangle, which is what we used, why we used 1/2 times B times H. So let's plug it in. So in place of P, we're putting 24. Whew, me and lead, man. Break it all the time. In place of H, we're putting 20. The 2 is in our formula, and then capital B is 24. So here we go, y'all. 24 times 20 is 480. And 2 times 24, oh my gracious, is 48. And now we're going to add 480 plus 48, and that's going to be 528. Need some units. We are dealing with inches, and because it's area, it's going to be inches squared. So our surface area is 528 inches squared. Alrighty. Next example, we again have a triangular prism. So I'm going to just start by writing the formula down. P times H plus 2 times B. Okay, so they've told us that the triangles are the bases. So I'm just going to color those in again. We've got that base. And we have that base. Again, remember the bases are parallel, which those are, and they're congruent. All right, let's start with P. So P stands for the perimeter of the base. We want to go around the outside of the base. So I've got 12. I have 10. Now the 7.3 refers to this dotted line. Does that help for perimeter purposes? Nope. because perimeter means around the outside. We are not worried about the inside. So we have 12, we have 10, and right here, it's not written in this triangle, but back here in that triangle, it is written as 9 centimeters, which means this one is also 9 centimeters, because remember the bases are congruent. So I'm gonna add the 12, the 10, and the 9 together, and that is gonna give us a whopping 31. All right, H. That means the height of the prism. So what is the distance between those bases? Right there. They are 21 centimeters apart. All right, now we're going to look for capital B. That means area of the base. Our base is a triangle. How do we find the area of a triangle? We do 1/2 times base times height. Now remember, when you are doing that in a triangle, and we said this in the last example, your base and your height need to form a right angle. In the picture, we got it right there. So the base is 12, and that's where the 7.3 comes in, because it is the height. So we have 1/2 times 12 times 7.3. So half of 12 is 6. And 6 times 7.3 is 43.8. So let's plug those numbers in. So in place of P, we have 31. In place of H, we have 21. Then we have the 2 because it's part of the formula. And then in place of capital B, we have 43.8. All right, so definitely I'm going to use a calculator for this one. So let me pull out my handy dandy calculator. All right, here we go. So we have 31 for P, 21 for H, plus 2 times B. We said B is 43.8. And I am getting, what is that? 738.6. So our surface area, 738.6, need some units. They are centimeters squared. Again, area always squared. Okay, so we've just talked about prisms. Just a real quick review. Prisms mean you have 2 bases. Those bases are parallel and congruent. The height of a prism is the distance between your 2 bases. All right? Now we're going to talk about cylinders, because remember we said cylinders are like prisms. They have 2 bases. Their bases are parallel and congruent, but their bases are not polygons, they're circles. That's why they get the fancy name of cylinder. All right, well, we have what are called right cylinders, which means that it makes a right angle right here. We also have what are called oblique cylinders, so they look like they're slanted, maybe tilted a little bit. This picture right here, this is called a net. This is just if you were to take your cylinder apart and flatten it out so that it is not a 3-dimensional figure. That's what it would look like. You have a circle on the top, you have a circle on the bottom, and in the middle, this thing right here that normally curves around, that's really just a rectangle. So we have a formula right here. T equals 2 pi r h plus 2 pi r squared. Now, and for some people, memorizing things is difficult, but here's what I want to show you. I want to show you of where that formula came from, because for those of you that can remember where it came from, then you don't need to memorize a formula. You will know what the formula is. So let me explain it real quick. All right, so remember, surface area means that you're going to add the areas up. So you have 2 circles, right? Well, how do you find the area of a circle? Well, we just spent a lot of time on circles, right? We did circles in chapter 11 and we did circles in chapter 10. So if you were finding the area of a circle, you would use the formula pi r squared. So both of these get pi r squared. That's where this comes from, 2 pi r squared, because we have 1, 2 pi r squareds. So that takes care of the 2 circles. Hopefully that makes sense. Now, let's talk about the actual rectangle. So in the rectangle, this part right here would be the height of your cylinder, how high it is, what the distance is from circle to circle, from base to base. But this piece right here, what does it represent? Well, let me tell you what it represents. So this right here is what would curve around the circle. So if you were to cut that out, that's the part that would curve around the circle. Well, what does it mean when you're going around the circle? That is circumference. How do we find circumference? Do y'all remember? Circumference of a circle is 2 pi r, and we've used that in some of the chapters. So from here to here really is 2 pi r. And because this is a rectangle, how do you find the area of a rectangle? You do length times width, or base times height. So 2 pi r is the length, h is the width, height, whatever you want to call it. That's where this comes from. That is finding the area of that rectangle. So those back here represent the two circles, and that right here represents the rectangle, and that's where it comes from. Again, look, let me show you this. Remember we just did this formula? Oh, it helps if I would write it correctly. We were just working with this formula for several examples. So the B, the base, circles, pi r squared. So 2 pi r squared. Again, that's where that comes from. Here we have the h for the height, perimeter. Remember when we talk about circles, we don't use the word perimeter because it's not a polygon. We use circumference. That's where the 2 pi r came from. So this formula is the same thing. They've plugged in the pi r squared for the B, and they've plugged in the 2 pi r for the P. That's the same thing as circumference, okay? That's where that formula comes from. So if you can learn that, then this will be easy. All right, so we're gonna find the surface area of this cylinder. So real quick, I am actually gonna write this down, and then I'm gonna say, okay, perimeter, we can't have perimeter of a circle, that's circumference. So circumference is 2 pi r, then I still have the h, then I have 2 times capital B. Remember, capital B means area of the base. The base is a circle, and that is pi r squared. So all I have to do is know this formula, and if I can remember what I know about circumference and area, then I don't need to memorize another formula, I just plug things in. So in this picture, let's talk about what we have. We've got 2 pi r. What's the r? The r in the picture is 4. The height. Remember, the height means the distance between the bases. So down here, it's kind of like there's understood to be this other circle. So you have the circle here and the circle here, and how far apart are they? They're 5 inches apart. All right, plus 2 pi r. Again, we already said r is 4 squared. I think some of y'all will like this formula better. Okay, so let's do some math. I'm gonna start by dealing with those numbers and kind of ignore the pi for just a moment. So 2 times 4 is 8, and 8 times 5 is 40, and then I still have the pi with it. Back here, I gotta do the exponent first. 4 squared is 16, and 16 times 2 is 32. Again, I've got the pi with it. Now those are like terms because they both have pi. So 40 pi plus 32 pi is 72 pi. And then we can use our calculator. So I'm gonna do 72 pi. Oh, I must have it on math print. Sure do. Come on. Okay, let's try that again. 72 pi, see what we get this time. Let's do 2 digits behind the decimal point. So we got to look at the third digit, which is a 4. It tells us to keep the 9 the same. So we're going to do 226.19. I'm going to use an approximate symbol because we're rounding. And then we need units, and our units are inches, and it's area, so it is squared. So some of you might really like this formula. Okay, so we got 2 pi r h. Again, that's the circumference times the height, plus 2 pi r squared. That's 2 times capital B, because that's how you find the area of a circle. Now in the picture, they didn't give us the radius. What did they give us? They gave us the diameter, and the diameter is 7. And remember, we've practiced finding the radius. You just chop that diameter in half, which means that it is 3.5. So I'm going to have 2 times 5, no, not a 5, a pi. 2 times pi times 3.5, and then times h. Remember, h is the height of your cylinder. In this case, that is 6. Okay, plus 2 pi times 3.5 squared. All right, everybody ready? So 2 times 3.5, that turns to 7. 7 times 6 is 42, so I have 42 pi plus 3.5 squared. Not gonna lie, I'm gonna use a calculator on this one. It's Friday night. I got a bit of a headache. Okay, that is 12.25. And then we have to double it. So times 2, and that's going to give us 24.5. Don't forget your pi. Now let's combine those. So I'm going to add the 42 and the 24.5, which is going to give me 66.5. Again, don't forget your pi. And now I'm going to use calculator again. So 66.5 pi. Remember, I already changed it so it's not in math print. So I'm going to get 208.92, because the 5 is going to round that one up. So use the approximate symbol. 208.92. Need some units. Feet squared. Ta-da! I think y'all probably will like that formula. Okay, so next one, and this is going to be where we stop for this particular video, and then tomorrow we'll pick up with pyramids, cones, and spheres. But we're going to just today focus on prisms and cylinders. We're going to do a little bit at a time. All right, so let me just go ahead and write the formula down, because I already see the word cylinder. So I have 2 pi r h plus 2 pi r squared. All right, here we go. So it says the surface area of a right cylinder is 200 square centimeters. Okay, right away, this is already a different problem, because they have told us the T. They've told us the surface area. If the diameter of the base is 10 centimeters, so how does knowing the diameter help us? Well, if we chop that in half, that'll give us the radius. So the radius is going to be 5. Then the question is, find the height. So in place of T, we're going to put the 200. And in place of R, I'm going to put the 5. And we do not know the H. Okay, so a little bit different, no big deal. So we've got 200 equals, let's do some math. So 2 times 5 is 10. So I'm going to write 10 pi h plus, back here, 5 squared is 25, and 25 times 2 is 50. Also, don't forget the pi, so 50 pi. And our goal here is to solve for h. So I need to get everything away from the h. So a couple things need to go. Obviously, I need to get rid of the 10 pi. I also need to get rid of the 50 pi. Which one do I move first? That one. How do I move it? The opposite of what I see, which is going to be subtraction. So I'm going to subtract 50 pi on each side. Now notice the 200 doesn't have a pi. So I can't subtract those and make it 150 pi. So I'm going to write 200 minus 50 pi. Just write it like we see it, because they're not like terms. You can't subtract them right now. And then that's still equal to 10 pi h. Now our goal is still to get h by itself. So we know we need to get rid of the 10 pi, but how do we do that? Well, the 10 pi is joined to the h by multiplication. So we're going to do the opposite of that, which is division. All right, so here's what I have right now. 200 minus 50 pi over 10 pi equals h. And I'm going to use a calculator. I cannot stress this enough. The way you use your calculator is going to make a difference in whether or not you get the right answer. Now let me show you. If you have a calculator like this, and you can do Math Print, man, I love Math Print. Let me show you how that would look. Why would I choose to use Math Print? Well, because I can use that fraction button. Y'all see it? I've got a fraction. So in the numerator of my fraction, I've got 200 minus 50 pi. So I'm just typing it in just like I see it on my paper. And in the denominator, we have 10 pi. So if you have Math Print, it's pretty awesome. Type it in like you see it, hit enter, and we're gonna get approximately 1.37. So H is approximately 1.37. Now we need some units. We're dealing with centimeters. Am I gonna square those centimeters? No, because this is not for area. This is the height. So do not square that. But let me go back to this calculator, because some of you guys are gonna use your phone or you're gonna use a different calculator, and that's totally fine. However, if you don't have Math Print, that changes the game. So let me show you what happens. If I were to type that in like I see it, so 200 minus 50 pi divided by 10 pi. You notice we definitely did not get the same answer because the calculator follows the order of operations. So a couple things to keep in mind. If you have a calculator and it doesn't have Math Print, one thing you're gonna wanna do is this part right here that's in the numerator, you're gonna need to put it in parentheses. That means you're telling the calculator that that entire value needs to happen first before you can do the division, okay? Secondly, then you're gonna hit division, which you know on your calculator shows up like that. Then when you type in 10 pi, guess what's gonna happen? You also have to put it in parentheses. Let me just explain what happens if you don't. If you type it in like this, it's gonna do all of this math first, which is awesome. Then it's going to divide by 10, and then whatever answer it gets, it's then going to take that and multiply it by pi. But if you put the 10 pi, all of it, in parentheses, it's gonna do this math first, then it's gonna do this math, and then it's gonna take this numerator answer and divide it by your denominator. So let's see if we're gonna get that same answer using that. So parentheses, 200 minus 50 pi, close my parentheses, so I got my whole numerator, divided by, now in another set of parentheses, I'm gonna plug in the denominator of 10 pi. So I'm telling the calculator, do those separately and then divide those answers. And yes, we get the same answer that we should have gotten. So it is doable to do it without Math Print, but if you have a calculator with Math Print, it's even better. Okay, guys, so you have a homework assignment. You have a worksheet that came in your packet that you guys picked up last week, and you are just working, I want to say on 1 through 8, but give me a minute. Let me pull up the lesson, RenWeb lesson plans, make sure I'm telling you the right thing. I'd hate to tell you the wrong thing. Yes, 1 through 8. So all you're working on are prisms and cylinders. Then tomorrow's video, we will do cones, pyramids, and spheres, and that's when you will work on the last part of that worksheet, which would be 9 through 16. So tonight, just do 1 through 8, just work on pyramids and cylinders, and I will check in with you guys in the next video where we cover the remainder of the shapes.